Hello Manoj, I am audible. Please just confirm me whether I am audible or not.
Yes, 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 sir. You are audible.
Okay, okay. Let us wait 2-3 minutes. Maybe some another participant will join. Then we'll start.
Yes, sir.
Please
Okay.
wait few minutes. Yes. Okay.
Thanks.
Okay, let us start. The first question is a highly viscous fluid flowing at a low velocity is called steady flow, uniform flow, turbulent flow, or laminar flow. So please try to write your answer in the chat box. Okay, Manoj is telling D option for question number A1, and Mangalchand also you can write your answer in the chat box. Okay, Amit is also joined. So please try to write your answer in the chat box. Question 1. A highly viscous fluid flowing at a low velocity is called a steady flow, uniform flow, turbulent flow, or laminar flow. Which option will be correct? So Manoj is telling D. Okay, laminar flow. Manoj is telling. Please, you can also write your answer, Amit and Mangalchan, in the chat box. Okay, Amit is also telling yes. Highly viscous means here the viscosity is more. That is the viscosity is, as you know already, the Reynolds number is rho v d by mu. This is related to your viscosity, right? And if viscosity will be more, definitely your Reynolds number will be low. Rho, low Reynolds number means your flow is laminar. Just this is the qualitative exam question here, not quantitative way, how much Reynolds number, but just for qualitative understanding, if your viscosity will be more, then definitely your laminar flow, that is your flow will shift towards the laminar. Now we'll move on the next question. Next question is vorticity is thrice of the rotation, twice of the rotation, 1 to 1.5 times of the rotation, none of the above. Which option will be correct for question number 2, please? Please try to write your answer in the chat box for question number 2. Okay, Amit is telling C option. Okay, good. That is a 1 to 1.5 times of the rotation. Okay. Other student, please also you try to write your answer for question number 2. Vorticity. Okay, Manoj is telling C. Okay, 1 to 1.5. So remember please, your vorticity is 2 times of the rotation. Always remember your vorticity is 2 times of the rotation omega. Always remember this is a vorticity symbol. Next question is, here you can see the detailed solution. The vorticity field is the curl of velocity field and is twice the rotation rate of the fluid particle. Next question is, when a stream function exists. When a stream function exists, it means a flow is steady and incompressible, flow is uniform, flow is turbulent, and function represent a possible flow field. Which option will be correct for question number 3? Please think on that the question, then try to write your answer. Please everyone try to write your answer in the chat box. Okay, Amit is telling option C, the flow is turbulent. Manoj is also telling C. Okay, other student please also try to write your answer. So here question is, stream function exists means that is your flow is the function represents the possible flow field. If let us assume the stream function exists, means oh, if the water is flowing like that, stream function means what? You know already the two function, that is the potential line and your stream line, like that, right? So here the question is, let us suppose a water is flowing and the stream function of that flow water is exist means that function represent, that is the mathematical function represent the possible flow field. So remember, next question here is also given, if stream function exists, the flow may be rotational or irrotational. If the stream function exists, the flow may be rotational or irrotational, a possible flow field. If it satisfied the Laplace equation, in it is a case of rotational. Means here, let us suppose a stream function is given, right? Stream function is given. If it is, it may be rotational or it may be irrotational, right? And but if that function satisfy the Laplace equation, means the flow is irrotational. This is the condition. Next question. A stream function exists for a flow. If a stream function exists for a flow and satisfy the Laplace equation, then the flow is rotational and satisfy the continuity equation, irrotational and satisfy the continuity equation, irrotational and does not satisfy the continuity equation, and none of the above. Please just think on that. Just I have discussed about the Laplace and stream functions. So based on that, you please try to write your answer in the chat box for question number 4. Amit is telling 4A and Manoj is telling 4C. Okay. So 4A means here, if just I have discussed here, if it satisfy means if a stream function satisfy Laplace equation, then irrotational. Definitely or maybe B or C will be correct. So A will not correct because the question is and satisfy the Laplace equation also. So definitely it should be satisfy your continuity equation as well as rotational equation. So option B will be correct for question number 4. Here just you can see the detailed solution. If a stream function exists, it is a possible case of fluid flow satisfy continuity equation which may be rotational or irrotational. If the stream function satisfy the Laplace equation, it is a case of irrotational flow. Remember please. Next question. Question number 5. When velocity potential exists in a flow, it means when the velocity potential exists in a flow, it means flow satisfy the condition of rotational flow, vorticity is non-zero, flow satisfy the condition of irrotational flow, all of the above. When velocity potential function is exist, remember please. The question here not about the stream function, about the velocity potential function. So please try to write your answer for question number 5. Okay, maybe A. Okay. Other participant, please. Okay, let me just show you the answer. So here, when the velocity potential function exists in the flow, it means flow satisfy the condition of irrotational flow. Remember please, flow satisfy the condition of irrotational flow. Remember always. The existence of velocity potential function guarantee the irrotational flow. But here just you can compare two things, stream function as well as your potential function. Potential function. If the your stream function exist means it may be rotational, it may be irrotational. But if velocity potential function exists, it's guarantee the flow is irrotational only. But let us suppose you have the only data for calculating the stream function. You have only the calculation, you can do only the calculation for stream function. So just when you will, or you need to try to calculate whether it is rotational or irrotational. So what you will do, you just try to calculate the Laplace. Just you will check the whether it is satisfy the Laplace equation or not. If it is satisfy the Laplace equation, the flow is irrotational. But if let us suppose if you have the flow field and you try to find out whether it is irrotational or rotational. So if possible, first you try to calculate the velocity potential function. If potential function is exist means the value will be, when we will calculate, means the value will be equate 0, then it means your flow field is irrotational. No need to calculate the stream function. But if you are able to calculate only the stream function, so you need to calculate, you need to check also the Laplace equation whether it is satisfied or not satisfied. If satisfied, irrotational, otherwise rotational. So this is the benefit of your potential function. Okay. So for a stream function, here you have the two-step calculation. First one, whether it is stream function exist or not exist, and second one, Laplace for getting rotational or irrotational. But in velocity potential function, only you have the one step calculation. If it is satisfied, then irrotational; not satisfied, rotational. So this is the benefit of your velocity potential function. Now we'll move on the next question, question number 6. The the deletion of viscous term from the Navier-Stokes equation lead to, means if you will delete the viscous term from your Navier-Stokes equation, then the remaining equation known as Bernoulli's, Euler and the Torricelli as well as your Darcy's. Which one? Please try to write your answer in the chat box for question number 6. Okay, Manoj is telling B. Okay, Manoj is telling B. Okay. Other student, please also try to write your answer. Okay. So here, actually, you have, let us assume Navier-Stokes equation. From Navier-Stokes equation, you are going to delete this one, the viscous term. That is the force due to viscosity, right? After removing the force due to viscosity, your remaining equation will be Euler. Remember, please, Euler equation. The remaining equation will be Euler. Question number 7. In fluid mechanics, the continuity equation is a mathematical statement embodying the principle of conservation of momentum, conservation of mass, conservation of energy, none of the above. Which option will be correct for question number 7? Please try to write your answer in the chat box for question number 7. Okay. Manoj is telling C, conservation of energy. We are talking about here the continuity equation. So please think again and try to write your correct answer here. Conservation of energy is not correct. Other student, please also try to write your answer. In this question, actually, I'll discuss about little bit the Euler equation as well as your Navier-Stokes equation, how the difference. Okay. So your continuity equation basically, your continuity equation is the conservation of mass. Remember please, continuity equation is conservation of mass, and Bernoulli's concept is based on your conservation of energy. Always remember. But let us discuss about these two terms, that is your Navier-Stokes equation and Euler equation. So let me write in the x direction your momentum equation, which is derived by your Euler concept. Euler derived by Euler, and x momentum in x direction. Let us assume x in this direction and y. We are assuming here 2D. So steady, what is happening? Okay. So here x in 2D direction. So remember please, we are considering here a steady and incompressible. Incompressible flow. So here you have u del u by del x plus v del u by del y is equal to minus 1 by rho del p by del x. This is your Euler. Now Navier-Stokes equation. Let me just write. Then you can interpret it in x direction. So here your u del u by del x plus v del u by del y, yes, is equal to minus del p by del x 1 by rho definitely will be here, and one extra term will be here 1 by r delta del xx by delta x delta xy del y. So remember, this is your extra term due to the viscosity. Just for your representation, just I have written here, nothing more conceptual. So just here you can see, after removing the viscous term due to the stress, shear stress term from here, what is, if you will compare, the equation is same after removing. So this was the meaning. Now we'll move on the next question. Question number 8. 7 we have already seen. The question number 8. the bodily movement of a fluid element from one position to another in such a way that its new axes are parallel to the original axis is defined as linear deformation, angular deformation, linear translation, none of the above. Which option will be correct for question number 8? Please try to write your answer for question number 8. Body movement of a fluid element from one position to another in such a way that its new axes are parallel to original axis is defined as linear deformation, angular deformation, linear translation, none of the above. For question number 8. Okay, you are telling C option. Manoj is telling C. Linear linear translation. Okay. Other student, please also you can try to write your answer in the chat box. The meaning of question is, let us suppose your a fluid element is this, and the axis in this direction x, and in this direction y. Right. After movement, let us suppose it is move here, but the axis is same. If in this direction, whatever the, if from horizontal, let us suppose angle is 10 degree, so here also from the horizontal your angle will be 10 degree only. This is y, this is x. The axis is parallel. These two line is parallel. So if you will go the angular deformation, this will be correct, this will be wrong. Linear deformation or linear translation, these two options remaining. So whether you will go with the deformation or translation. Deformation means, let us suppose a fluid element like that, or deformation means your fluid element will be like that, maybe deformed, or maybe like that, deformed. Translation means if the shape is like that, similar shape here, that means your fluid particle translate one position to another position. So now please think again and try to write your answer in the chat box. Everyone please write your answer in the chat box. Okay, let me just show you the answer. So here is linear translation. Linear translation, remember please. Next question. The linear translation is the bodily movement of a fluid element from one position to another in such a way that its new axis parallel to the original axis. Remember please. Question number 9. Question number 9. During the filling the blanks, there is no shrinkage, stretching or rotation of fluid element. Linear deformation, angular deformation, linear translation, none of the above. Which option will be correct? Based on the previous explanation, you try to write your answer in the chat box. Please, everyone. Everyone, please try to write your answer in the chat box. Based on previous explanation. Okay, it should be C. Okay, for question number. Okay, you are telling for question number 9. C. Okay, other student, please also try to write your answer. Okay, let me just discuss. So here is, yes, definitely option C is correct, linear translation, because no shrinkage, whatever we have discussed, no shrinkage, stretching or rotation of the fluid element. So definitely, oh sorry, your linear translation will be correct. Option C will be correct. Next question is, what are the independent variable in Navier-Stokes equation? XYZ rho, XYZ mu, XYZ rho t, XYZ t. Independent variable we are talking here. Try to write your answer in the chat box, please. Everyone, please try to write your answer. You are telling the C option. Okay. Manoj is also okay. Manoj is telling C. Okay. For question number 10. Other student, please also try to write your answer. Okay, let me just show you. Yes, the option D will be correct here. The independent, we are talking about here the independent variable x, y, z means independent means what? Let us suppose the variable two types. Independent, just I'll tell in the very simplified way, and dependent means let us suppose you have y is equal to f of x. So here you are independent to put the value of x. Maybe you can put 1, maybe you can put 2, maybe 3, whatever you want. Based on x value, your y is dependent. So here y will be the dependent value. So question is asking about your independent only. So you are free to put x means you are free to identify the fluid properties at any particular location x, y, z in the equation of your Navier-Stokes, whatever I have discussed earlier. Remember, please. So independent equations your that is independent variables are x, y, z and t. Now I'll move on the question number 11. Navier-Stokes equation are coupled, uncoupled, exponential or radical system of equation. Just please try to think and try to write your answer in the chat box. Whether it is coupled, uncoupled, exponential or radical. For question number 11, please everyone try to write your answer. Eleven A, okay. Manoj is telling a coupled system. Other student, please also try to write your answer, whether it is coupled or uncoupled, is exponential or radical. Please, you can also write your answer in the chat box. After that, I have another set of question, 12 question. Set of 12 question will solve after this. Okay. So your Navier-Stokes equation is the coupled system. Remember always, please. Here, the meaning, the Navier-Stokes equation are called coupled system of equation because all of the equations should be solved to get the dependent variable. Because all of the equations should be solved to get the dependent variable. All of the equations means x direction, y direction, z direction continuity equation, and equation cannot be solved separately to get the unknowns. Means if you are going to calculate the unknown value, that is combinedly, the combined of the equation, that means the couple, and the vice versa is uncoupled. So the next question, question number 12, important question. Okay, the Navier-Stokes equation are all partial differential equation. Here is the Navier-Stokes equation are the partial differential equation. What will be the best reason behind it? What will be the best reason behind it? Why partial differential? The ordinary differential equation are not present in Navier-Stokes equation. The dependent variable are function of all independent variable. Each dependent variable depend on only one of the independent variable, and the partial differential are only present in the Navier-Stokes equation. So please try to calculate. Try to actually write your answer in the chat box. Everyone, please. For question number 12. Everyone, please try to write your answer. Okay, I think 12B. Okay. Dependent variable are function of all independent variable. Okay. Okay, this is the, you are telling the option P, that is the dependent variable are function of all independent variable. This is the reason behind the Navier-Stokes equation is partial differential equations. Okay. Other student, please also try to write your answer in the chat box. After this question, I'll take 5-minute break. You can also take. And after that, we'll solve the new set of questions. 12 questions again. This was your from hydraulic engineering NPTEL assignment 2024, and the next one will be 2023 hydraulic engineering, same same subject. Okay, other student, if you want to write your answer, you can write. Otherwise, I'll just show you the. Okay, let me just show you. So option B will be correct. Yes, you are correct. The dependent variable are the function of all independent variable. Each dependent variable in Navier-Stokes equation depends on all of the independent variables. So partial differentials are used to indicate that the other independent variables should be kept fixed while differentiating. Just the differentiating rule of the partial differential equation is written here. But the reason behind, because all dependent variable means y is equal to f of x, what I was telling, y is the dependent, remember please. So all dependent variable are the function of independent variable, that is x, y, z, t. Remember please. So this is about your question number, that is the assignment of hydraulic engineering 2024. Previous year. Now we'll move on the question, next one, this 2023. So I'll take 5 minute break here, please. So you can also take. Okay, so the next set of question is, the first question is, let me just discuss. The laminar viscous flow is characterized by the Reynolds number which is less than critical value, equal to critical value, more than critical value, and none of the above. So laminar or viscous flow, you can say. The laminar flow is characterized by Reynolds number which is less than critical value, equal to critical value, more than critical value, none of the above. Which option will be correct? Please everyone try to write your answer in the chat box. For question number 1. Okay, so critical value means here is, you can just think about it. After that value, your flow characteristic change. You just remember these things. Let us suppose after a certain value, your characteristic will be changed. Like the fruit number. If the fruit number is 1 is critical, after just if the fruit number below 1 means your flow will be subcritical, more than 1 will be supercritical, or whatever. So like that, here is also critical value. After that, flow characteristics will be changed, maybe laminar to turbulent or turbulent to laminar. So that value is critical value. So just now think on that and try to write your answer. Anyone please try to write your answer. Okay, Manoj is telling A option, less than critical value. Other student, anyone want to comment? Anyone please write your answer for question number 1. Okay, so yes, A will be correct here. Remember please, as you all know, the for pipe flow, let us assume Reynolds number less than equal to 2000, somewhere 2100, somewhere you will find 2300. So we'll consider 200, 2000. So if the value is less than or equal to 2000, this is laminar. So the critical value is this, for pipe flow is 2000. This is the critical value here. If let us suppose your, if we are assuming this 2000, if your value, let us suppose Reynolds number will be, let us suppose 2500, means your flow is turbulent. Okay, less than the critical value is, yes, correct. Your answer is correct, because we are talking about here the laminar flow characterized by less than the critical value. Okay, so here you can see the laminar or viscous flow is characterized by the less than the critical value. Good. The next question is the ratio of maximum velocity to average velocity for viscous fluid flow between two parallel plates A 1, B 2, C 1.5, D 2.5. So please everyone try to write your answer in the chat box for question number 2. Okay, got it. Okay. So 2B you are telling 2. Other students please also try to write your answer. Here the question is about parallel plate, two parallel plate, the maximum velocity to average velocity. Manoj is telling 2B, that is 2. Other student please also try to write your answer. Other student please also try to write your answer. So here I'll discuss a little bit about your parallel plate as well as your pipe. How the velocity maximum ratio of maximum to average velocity changes from the difference between actually parallel plate flow as well as your pipe flow. First, okay, 2B. Okay, let me discuss here. So the question is asking about parallel two plate means let us suppose here you have the plate 1 and plate 2. These two plate is parallel 1 and 2. So U max is equal to 1.5 times of U average in parallel. But in case of pipe flow, water is flowing in this direction, U max is equal to 2 times of U average. Remember please. Always remember. So this is the fundamental difference in magnitude. Okay. So now we'll move on the next question. Next question is question number 3. The vorticity represent of the fluid. The vorticity represent the fluid properties of kinematic, transport, thermodynamic, other miscellaneous. Which option will be correct? Vorticity. If you want to put vorticity in which category, whether it is kinematic property, transport, thermodynamic or other miscellaneous. That is the none of these three: kinematic, transport and thermodynamic. The vorticity. Please try to write your answer, everyone. For question number 3. Okay, Gopal is telling option A, kinematic. Other student, please. Other student, please try to write your answer. Very simple one. Just think on that in which topic you have studied this vorticity. From that you can guess. Okay, definitely. Pal is correct. So it is your actually the vorticity is kinematic properties. Next, we'll move on the next question. Here you can just see the kinematic properties: linear velocity, angular velocity, vorticity, acceleration, and strain rate. Transport properties: your viscosity, thermal conductivity, and mass diffusivity. Thermodynamic properties: your pressure, density, temperature, entropy, and enthalpy. The next question is question number 4. Which of the factor primarily decide whether the flow in a circular pipe is laminar or turbulent? Prandtl number, pressure gradient along the length of the pipe, dynamic viscosity coefficient, and Reynolds number. Which option will be correct, please? Very simple question. So everyone please try to write your answer for question number 4. Very simple question. The vorticity, Manoj, you are asking about the vorticity. If you know the rotation, so when you will multiply the rotation value with 2 times, then you will get the vorticity. The vorticity is nothing. Vorticity is just 2 times of your rotation. Everyone please try to write your answer for question number 4. Very easy question. So just read the question very carefully and try to write your answer. Okay. Gopal is telling B. Manoj is also telling B. Okay. Other student, please. So if let us suppose water is flowing in the pipe and someone just tell you please find out the whether it is flow is laminar or turbulent, how you will get? Whether you using Prandtl number, pressure gradient, dynamic viscosity coefficient or Reynolds number. Please everyone try to write your answer. Okay, this was the very basic question. So I was expecting correct answer from all participants. Okay, so let us suppose you all know how we will decide whether flow is laminar or turbulent. Reynolds number. Very simple. Okay, we'll move on the next question. D option will be correct for this. As you all know, the high Reynolds number flow greater than 4000 are turbulent flow. We are talking about here the pipe, remember, pipe flow, circular pipe. Whereas low Reynolds number less than 2100 are laminar flow, and the viscosity coefficient is a part of the Reynolds number but isn't the only criteria for decision. Okay. So Navier-Stokes equation is derived from Euler equation, continuity equation, first law of thermodynamic, Newton's second law. Which option will be correct? Please everyone try to write your answer. Question number 5. Very important question. So everyone please try to write your answer. Everyone. So very simple question. Please everyone try to write your answer. Just think on that. Okay. So you all know for the derivation of any momentum equation in case of fluid mechanics, whether if you will derive the Euler equation or Navier-Stokes equation based on only the Newton's second law. Always remember, please. So now we'll move on the next question. Next question is Question number 6. The stress tensor tau Ij is a tensor symmetric, asymmetric, isometric, non. Stress tensor tau Ij is a tensor. So please everyone try to write your answer. Little bit advanced but not much. So please. 'Please you have for this question 2 minutes. Please within 2 minutes try to give the answer. Six A symmetric. Okay. Other student, please also try to write your answer. Okay, definitely it will be the symmetry. Okay, the next question. Okay, here answer is visible. So which of the following flow have the highest critical Reynolds number? Flow in pipe, flow between parallel plate, flow in open channel, flow around a spherical body. Highest critical Reynolds number. So please just I want from your side the value. What should be the value? And here what should be the value? And for this and for this. What should be the value? Please everyone. The answer is 1 and you know already answer is A means the flow in pipe have the highest critical Reynolds number. But how much? For parallel plate how much? For open channel how much? And for your spherical body how much? So we have the discussion. I'll show you. Just please first you try to write your answer here. Everyone please try. Okay, please anyone just try to write your answer. As I have just discussed before in the previous question, the critical value for the pipe 2000. Similarly, parallel flow. Similarly, please try to write for open channel. Okay, after 1 minute, I'll just show you the answer. So within 1 minute, if anyone want to write, please you can write. Okay, let me just show you the answer. So the answer is for a pipe flow, you have that is for pipe flow 2000, flow between parallel plate you have 1000, and flow in open channel 500, and flow around a spherical body is 1. So just you can see. The next question is question number 8. Okay. The flow through a circular pipe is laminar. Here the question in question is written the flow is laminar. Now the fluid through the pipe is replaced with one more viscous fluid and pass through the pipe again with the same velocity. What can we say about the nature of flow? Nature of this flow will become turbulent, will become transient, remain laminar. Reynolds number of the earlier flow is required to answer this question. So which option will be correct for question number 8? Based on your reasoning of, based on your understanding of the previous week class, that is the NPTEL lectures. So just please think on that. Read question very carefully and try to write your answer. First read the question very carefully. Please everyone read the question very carefully and try to write. Okay. Manoj is telling C. 8C. The flow will remain laminar. Okay. Other student please also try to write your answer. Based on your just understanding of previous classes, just try to write your answer. After that, maybe I'll take 2 classes more. That is week 11 and week 12. Other student, please try to write your answer. The flow through a circular pipe is laminar. First the condition is given. Now the flow through the pipe is replaced with a more viscous. Here you are going to add more viscous fluid. to pass through the pipe again with same velocity. Velocity you have the same. What can we say about the nature of this fluid? Okay, you all know one thing, the Reynolds number. Re is equal to rho average velocity into if circular pipe, that is diameter d, and mu. So definitely you are going to replace the fluid. So your Reynolds number will depend on density as well as your dynamic viscosity. But dimension will be same and velocity will be same. So here initially your flow was laminar. After choosing the another fluid with have the, that is the more viscous fluid, that is the mu value is increased here. If the mu value increase, definitely your Re value will be decrease. But also it depend on your rho, whether you are going to choose the rho value is how much. But the rho value is not given here. But again, if your velocity, that is your dynamic viscosity, is going to increase, means Reynolds number will be decrease. So definitely your flow remain laminar. Okay. A flow through, just you can see the explanation. A flow through a circular pipe is said to be laminar when the Reynolds number is 2100. A more viscous fluid would have a higher velocity coefficient, thus reducing the Reynolds number further at same condition. Hence the Reynolds number of will be well below 2100. The flow will be laminar. Here is not velocity coefficient, I think. The viscous value should be more. The dynamic viscosity coefficient, I think, not your velocity. So remember, some typing mistake. Okay, the next question, very easy question. When a problem state the velocity of the water flow in a pipe is 20 meter per second, which of the following velocity is it talking about? RMS, average, absolute velocity, or relative velocity? Question number 9. Everyone please try to write your answer in the chat box. for question number 9? Everyone, please. Okay, 9B, average velocity. Okay. Other participants also please try to write your answer. Other participant, please also try to write your answer in the chat box. Other student, please, anyone want to write? I think these questions we have already solved in the previous classes also. Okay. So question 9 is about one. Let us suppose in a question just velocity is given 20 meter per second. It means the value is average velocity is given. Remember always. Option B will be correct definitely. Manoj is correct. Now we'll move on the next question. Question number 10. Here you can see the explanation. In a pipe flow, the velocity is always referred to be average velocity. There may be a case where all the water particles move in the same direction with 20 meter per second, then the average velocity will be equal to the absolute velocity. But this is only a special case, hence average velocity will always be true. Remember please. Meaning of a special case, what is written here, just try to, just if I want to show you, let us suppose a pipe flow is given. You know already the velocity diagram is like that for laminar parabolic, but in a special case, let us suppose this is something different, not pipe. So your velocity at everywhere, that is the roughness is very zero and all. So your velocity, all particle moving in the same direction with same velocity, means when you will take the average and your absolute value will be the same, but here average different and maximum value will be the different. So that is the special case, this one. So this case is impossible, because definitely the practically, that is in the channel flow or pipe flow, definitely impossible, because at the surface velocity will be zero. Remember, always remember please. So in that case your average velocity and absolute velocity will be same, but this is not possible. So always average velocity, remember. So this was the explanation. Next question is question number 10. The volume flow, the volume rate of flow Q between two streamline psi1 and psi2 is equal to volume flow rate. Option A is 0, option B psi1 into psi2, option C psi2 minus psi1, and option D psi2 plus psi1. Which option will be correct for question number 10? Everyone please try to write your answer. For question number 10. Very important question. Okay, maybe 10C. Psi2 minus psi1. Okay. Other student, please also try to write your answer. Here, no need to write you correct answer only. You can write whatever you are know, whatever you have understanding about the question, you can write. There is no issue here. So please try to just write your answer for question number 10. Okay, Manoj is telling option C, psi2 minus psi1. Okay. So I'll give another 1 minute. So within 1 minute, please try to write. Other participant also. Within 1 minute. Okay. Okay, no one. So let me just show you the answer. So definitely the your psi1 and psi2 will be okay. Option C is okay. I think in the previous year GATE exam, so the question is similar, but the magnitude, remember please, at the place of psi1 and psi2, magnitude was there. Let us suppose 4 unit, the psi1 value is 4 unit and psi2 value may be the 8 unit. So how much your volume flow rate? Definitely 8 minus 4, that is 4 unit. So this was, I think, just I have remember. So you can go through the previous year questions, so you will definitely find out this such type of question in the GATE kinematic chapter. Next question. Okay, question number 11. For a fully developed pipe flow, how does the pressure varies with the length of pipe? Linear, parabolic, exponential, constant. For a fully developed pipe flow, how does the pressure varies with the length of pipe? Read very carefully the question and then try to write your answer in the chat box. For question number 11. Everyone please. Very important question. Fully developed pipe flow means, okay, and the flowing covering entire diameter, okay. Oh, your meaning is flowing covering in. No, 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 not the meaning of fully developed. Okay, so let me discuss depth. Okay, before after discussion, I'll just tell you the answer. So fully developed means what? Let us suppose a pipe, as I have discussed many times. So as your flow will enter in the pipe, let us suppose flow is entering. So due to the roughness of this material, due to the roughness of the pipe and your viscosity, here is the no slip condition. So boundary layer will be formed here like that, and the boundary layer from this side also will be formed. Very simple. I am going to try to tell you in very simplistic way. So here your velocity will be vary like that. Also from this side velocity will be vary, but in this region your velocity will be constant. Similarly, in this region your velocity will be constant. Here velocity will be constant. Up to that velocity, here is 0, here is little bit more, little bit more, little bit more, little bit more, but here is constant throughout. And similarly here also velocity varying this much and this is constant. After that, after few distance, your velocity varying entirely. That is, here velocity is different, here is different, here is different, here is different. That is for laminar. If the flow is laminar, this graph will be parabolic. So remember please, so this is the your fully developed flow. After that, this is the fully development length of the flow, and fully developed flow means after the fully developed of flow, the velocity diagram the velocity diagram will not change. The velocity diagram will not change after the fully development. But here just you can see within the fully developed length your velocity diagram is changing, because here is velocity varying up to that much and then after your constant value. The diagram is not correct. This is and this is and then constant. So here you can also see constant, but here is after fully developed the velocity is changing. Here is up to that much your length is constant, here little bit less, here little bit less. If you will draw here, it is very less your constant velocity. But here parabolic, complete parabolic, after that complete parabolic, complete parabolic, there is no change in the velocity diagram. So this is the meaning of fully developed. Fully developed flow means the water flow velocity will not change. So but here is question was, is the fully developed flow how the pressure varies with the length. If this is the length of the pipe x direction, how the change. Definitely you know all the linear variation, because as you have aware dp by dx the many times in Euler equation I have also shown you, and also already actually I have shown you, and in Navier-Stokes equation also I have shown you. Okay, the next question is, here you can see in a zero acceleration fully developed flow in a pipe, the pressure gradually decreases linearly along the length of the pipe, hence the pressure variation is said to be linear. Gradually decrease linearly along the length, remember please. Next question, question number 12. So the viscous force, the relative motion between the adjacent layer of the fluid in motion, which of the following fit base sentence? Oppose, never affect, and facilitates and may affect under. The viscous force, the relative motion between adjacent layer of the fluid in motion, which of the following fit best sentence? Oppose, never affect, facilitate, and may be under. May affect under. Which option will be correct, please? So please everyone try to write your answer in the chat box. Okay, Manoj is telling B option. Okay. So other student, please also try to write your answer in the chat box. This is the last question for today class. Then we'll meet again in the next Friday. Maybe on, let me just see the date, on 4th April. Okay, 12D. Manoj is telling D option may affect under. Okay. Previously we were telling B option never affect. The viscous force, the relative motion between adjacent layer of the fluid. That is here question is asking about the the viscous force, what does with your fluid motion, whether it is oppose, not affect, or may affect under or facilitate. The meaning is viscous force what does with your motion of the fluid. So please everyone think on that. So definitely you all know the your viscosity create the resistance in the flow, definitely it will be the oppose. Remember please, here you can just see the viscosity is an internal friction of the fluid in motion, and it is the property by the virtue of which the relative motion between two adjacent fluid layer is opposed. You know already. So thank you all. So we'll meet again in the next class. So now everyone can leave the class. Thank you. Thank you. Thank you, Manoj.